Okay, for our software engineering group project, we were tasked with redesigning the Amazon EC2 Launch Wizard. In this little presentation, we'll discuss what we exactly needed to do, why we did it, how we did it. Then we'll show you a small demo of the application, and then I'll hand over to Joseph to explain how our API gateway works and how we accomplished a few of the more technologically demanding tasks. So firstly, what exactly did we need to do? We were tasked with redesigning the Amazon EC2 Launch Wizard. In its current state, it's not very user-friendly or intuitive to use. It follows a very linear process, and we felt that we could make it a lot more user-friendly, a lot more intuitive, get rid of some unnecessary information on the screen to declutter the display a bit, and just improve the design a bit more by using a bit more popular design libraries. Then why exactly we did it? As I said, the current design is extremely outdated. Um, in today's technological landscape, the design doesn't really match up to its peers. If you look at applications like Heroku or Google Cloud that have much better looking UIs. The current flow on the EC2 Launch Wizard, as you can see over here, is also very linear. So you have to do all of the steps in a certain order, and that is not always very desirable. So one of the big things we wanted to change is giving the user the ability to start at any point in the process. And then probably the biggest thing we tried to do and we feel accomplished is to improve the layout and the design of the application. So how did we do it? We decided to tackle this project in React. React is a JavaScript framework / library that Facebook developed, and it has very good support for mobile development. It is you can write extremely responsive applications in it. It has very nice error handling, and probably the biggest reason for using React is its state management. As we all know, in normal old school JavaScript, managing your state is quite a hassle, and React makes it second nature. Then for our front-end server, we decided to use Next.js, which implements server-side rendering. And the big reason for that is that it returns fully hydrated pages to the browser, meaning your load times is slightly longer, but you don't have all of these spinners and loaders all over your page all the time. You have a much more complete UI from the start. And then primarily the biggest thing we changed was implementing Material UI, which is a very popular design library that almost every app in 2019 uses. And we feel it just elevated the design of the application a lot more. So next we'll do a quick demo of the application, and then I'll hand over to Joseph to explain how exactly we implemented our APIs. Okay, so now we're in our new application. As I said previously, one of the big things we wanted to change was to get rid of the linear approach. So what we decided to do is have all of these expansion panels with all of our different sections, and a user can start the process from any one of these expansion panels. The main things that you need to create a new instance is you need to choose an AMI, which is basically like your operating system. It's your machine image for that VPS that you're creating. Next, you need to create an instance type, which is basically if you can dumb it down, it's the hardware that you're running it on. After that, you need security groups, which you need to be able to connect to your new instance. Storage is the next big one. You can either use the default storage that is on your on your instance, or you can add additional Amazon EBS storage. Then we also have the tag section, which is just used for some internal bookkeeping if you want to annotate your instances better. And finally, we have a key pairs section, which is where we query all of the key pairs associated with your AWS account. So let's say we want to start the process. We go to instance type if we want to start there. Let's say we want to use a T3 Nano as our instance type. We can click on the little plus button and it'll add to our cart over here. We can remove that if we don't want that anymore and select a different one. And this is where we keep track of our selected configuration. So any of the steps that we follow in these expansion panels will be updated in our sidebar. Next, we can, let's say we want a Windows machine image. We can search for that. We've also implemented some pagination so that we only fetch 9 entries at a time and we don't flood the browser too much. So, for example, we'll select the Windows Server 2019 version, and as I mentioned, it'll add that to our cart. Next, we can either select an existing security group that is associated with my AWS account, or I can create a new one. So let's say I want to select this one. That will then copy all of that information over to this step, and I can edit it as much as I want to. So I can edit some new fields there. I'll just leave this the same because I don't need to change it. And then we have some default sitter IPs over here. We have a port range and the protocol we want to communicate over. Our protocols, we can either communicate over all protocols, over TCP, UDP, or allow specific ICMP messages. Then we can also add more rows to this security group, or we can just plainly save it, which will go and drop that in our cart as well. Next, we can add storage to our instance. So, for example, if I only want the root storage, I can just update that. Next, we'll add tags. And we can associate them either with the instance that we're creating or with the volumes that we're creating. So let's do name demo instance, associate that with our instance and our volumes, and we can save that, and same story, it adds it to our cart. And then finally, we need to select the key pair so we can connect to our instance once it's created. So I'll just select this one, which is one of the ones that I have associated with my account. Finally, when we're ready to launch the instance, we can click on this Launch Instance button on the right, which will allow us to review all of our settings. And finally, it will execute the final call. Cool, we see the green check mark. Then if I head over to my instances on AWS, we can see this new one is generated that we just created. It's busy initializing and it's running. And that's all we have for our demo. Next, let's hand over to Joseph to explain how we implemented our API gateway to be able to communicate with the EC2 API from our Node.js server.
We needed to implement an API gateway for our EC2 Launch Wizard to allow API requests to be made to get information that we need or to launch an instance itself. We came up with a flow involving 2 servers. The first server is used to host static resources like HTML files, JavaScript and CSS, and this is done with next.js. And the second server is written in Node.js using Express for our API gateway. So this implements all of the endpoints for things like getting instance types or launching an instance. And behind the scenes, this makes use of the AWS SDK for Node.js in order to communicate with Amazon. And This is making use of the EC2 APIs, the AWS price list API, and authentication is done using an IAM user with the credentials stored in a .env environmental variable file. And this can also be done using the metadata service if the Node.js server is running on AWS on an EC2 instance. We also implement a cache for certain endpoints like AMIs. We cache all of the AMIs locally. So some of the REST APIs that we've implemented in our API server allow you to get detailed information on all of the instance types. It allows you to get all of the security groups that a certain user has, and it allows you to get all of the key pairs for a certain user. In order for AMIs, we can get a list of quick start AMIs. This is used by the existing EC2 launcher, and it's a nice feature to have to get started quickly. We also implement a powerful search API. It allows fuzzy searches on a particular search term, and an offset and limit can be specified for pagination. And when we're ready to launch the instance, we just make a post to the launch instance API with all of the required details, such as the security group, the AMI, any EBS volumes and tags. And this will go ahead and create the security group, create all of the required structures, and then launch the instance. We do some caching locally, so all of the instance types have been collected from the price list API. We have a script that collects all of those and stores it locally as JSON. So when we make an API request to get the instance types, it's returning that local JSON data. And we've also stored all 41,000 community AMIs as local data. This takes about 36 megabytes. And the good thing about this is that for any fuzzy searches that we want to make, those searches can be made on local data, and it's very quick to return.